So we can see from a derivative plotter that the derivative of sine plots out a cosine graph, and the derivative of cosine plots out a sine graph. So we are now going to use these as defined derivatives. Okay, we didn't come up with these algebraically. We didn't apply the power rule or anything, but we're going to use these as defined derivatives. So these are ones that we use on our formula sheet. And again, we can justify this by just looking at some pieces here. If I take a look at the slope of sine, okay, at 0, this slope happens to be positive and is equal to positive 1. And if we take a look at this cosine value at 1, it's going to be positive 1. At pi over 2, we have 0. And if we take a look at the cosine value, it looks like it's 0. And at pi, if that original slope was positive 1, this must be negative 1, and the cosine value at pi is negative 1. So they seem to be matching. And then again, if we look at it from the other perspective of cosine, if I take a look at the slope of cosine at 0, the slope of cosine is 0, and I look at the y value at 0, yeah, it's going to be equal to 0. It matches. At pi over 2, the slope is negative 1. The y value on sine at pi over 2 is going to be positive 1. So it just seems to be the opposite sign. And then we get the 0 slope here, a 0 y coordinate. So they seem to be matching. And so if we just put a negative on that sign, which we did with the formula, we end up with the derivative function for cosine.